All right, so in this video, we're going to talk about the chain of responsibility design pattern. So what does that mean? Basically, it implies that there is a chain of so-called handlers. A handler is obviously a class or an object that can handle a request in some way. Okay, and we define a chain of handlers to process a certain request. This has some obvious advantages. So when you have multiple operations that need to be performed on a request, you can have a chain where each object in that chain handles its own operation, right? Rather than putting everything in a single class, you can have separate classes for separate operations. Okay, so that obviously helps with separation of concerns. So that is the main idea, defining a chain to process the request. Now, each handler, if we are talking about a chain, each handler needs to have a reference to the next handler, so that when a request has been processed in a certain way, or even if the request cannot be processed, then we can send, or the handler can send the request on down the chain to the next handler to perform its operations. And each handler then decides to process the request, decides whether or not to process the request. It has the option to not process it and simply pass it on to the next handler, and or pass it on, right? So there are two schools of thought here. One that says each element, each handler handles the request cannot pass it on. Okay, so the request has been handled. Or we can have a system where each handler adds its own functionality and then moves the request onwards down the chain. So these are two different strategies that obviously depend on the requirements of the project, right? We will see an example of this. And requests can be of different types, okay? So we don't necessarily have to have a single type of request. We can have multiple types, and we can actually send the request to various handlers in the chain. So we don't necessarily have to send the request to the first handler in the chain. We can send it in the middle somewhere if the functionality requires us to do so. So a quick visual representation of this: we have a request that is passed to a handler. The handler has the option to process the request, so then we get a result. Or if it cannot process it, it moves it on to the next handler to see if that one can handle it. Okay, so this is the situation where the handler, once the request is handled, then the handler breaks the chain. Okay, so we don't send the request onwards. So the request can move from handler to handler. At one point, it will be processed. If it cannot, then the request fails, or depending on the functionality of the project, you can have another way to handle that request. So that is one way. It's basically a chain, but actually there is another way to kind of structure this design pattern. So this is the chain, but we can also have a tree structure. So this is very evident in the way Android handles operations on its UI, okay, in its XML layouts. So here, for example, let's say we have a click of a button. That button will either handle that request, okay, or pass it on to the relative layout. If the relative layout cannot handle the request, it will pass it on upwards to the constraint layout, which of course can either handle it or let the request simply die out. Okay, so this is the chain of responsibility represented in an Android setting. If you've worked with Android before, you would be familiar with this structure. That is the typical chain of responsibility design pattern. All right, so let's move on to the IDE and put in practice, put into code one of these design patterns. Okay, so I'm going to call this chain of responsibility. Okay, so first of all, let's go ahead and define an interface called handler chain. Okay, and so what we're going to do here in this program is we're going to simulate a system that adds headers to a HTTP request. Okay, so the HTTP request has authentication headers, it has caching headers, it has a whole lot of headers that we can add to that request before we send it on to the backend API. So here we're going to simulate adding a few of these headers to a request. So the interface handler chain has a function called add header. And here we're going to have an input header of type string, and the whole function returns a string. So basically, each handler that implements this interface receives a input header and returns a updated header. Okay, so we are here in the situation where each handler both handles the request and passes it on to the next handler in the chain. So let's go ahead and implement the interface. First of all, I'm going to have an authentication header that has a val next has a token. Okay, so the authentication token of type string question mark, and it has a next, which is a handler chain that can be null. And here we implement the handler chain interface. Okay, so we're going to have an override function add header. Okay, and here we will simply return directly $input header. We're going to put a new line without any spaces. We're going to have authorization colon space $token. So these spaces here are quite important, or lack thereof, are quite important because when we will test this functionality, we need to know whether there's a space or not. Okay, so we have our token, and then we need to pass it on. So .let next question mark .add header it. And if we don't have a header, we're going to say question mark colon it. Okay, so we're just going to return the result. Okay, so this is our authentication header. Now let's add another header. Let's say content type header. Here we're going to have a val content type of type string and val next of type handler chain that can be null, and it implements the interface handler chain. So again, override add header. We're going to simply return $input header /n, and here we add this particular header. So we're going to have content type space dollar. We have the content type there, .let, and the .let is exactly the same. Okay, so we just copy and paste that. Okay, and let's add a final one, the body payload header, val body of type string, and val next handler chain equals null by default. And this will be a handler chain as well. Override the function, simply return input header /n, and here we have body. Okay, and of course .let next add header. Okay, so this is my chain. Now these are just the headers. The chain has not been constructed yet, so we will do that next. Let's go ahead and create our test class. So class chain of responsibility test. We're going to add a test function, fun test chain of responsibility. All right, so let's go ahead and create our elements. So first of all, val authentication header is going to be an authentication header. Authentication header. And here we need to pass our token, right? So here we have our token 1, 2, 3, 4, 5, 6, whatever that is. The next one is null by default. So let's just leave it at that for now. Then we have content type header. It's going to be a content type header. So the content is going to be JSON. And then we're going to have a message body, or what did we call it? Body payload header. It's going to be a body payload header. And here we need to have a body in the form of JSON. So we're going to have body : and curly braces. We escape the quotes, username, escape the quote, space equals space, escape the quote again. You can put your username here. I'm going to put John, and escape the quote again. So body is going to be username John in JSON format. Then let's construct our chain. So authentication header.next is going to be the content type header. And then I think this is a val, and we need to change it to a var so that we can update it. There we go. Okay, so authentication header.next, and then content type header.next is going to be the body payload header. Okay, so we have our chain. So let's go ahead and create a message. So I'm going to say val message with authentication is going to be authentication header dot add header, and the message is going to be headers with authentication. Okay, and then let's just go ahead and print line the message with authentication. So here we simply call the first header in our chain. Okay, but of course we can call a secondary header as well. So I'm going to say val message without authentication. And here, instead of calling authentication header, I'm just going to jump into content header, add header, and here we'll have headers without authentication. Okay, and I'm going to print line this message as well, message without authentication. Okay, so let's go ahead and run this just to see the output that we get. All right, so here we have we should actually, you know what, let's put a divider here so that we see where those two start and finish. Okay, so the first one, you can see headers with authentication. We have our authorization, content type, and body. And then without authentication, we have everything else apart from authorization. So let's add some assertions as well here. So assertions, use the assert j1 dot assert that message, I'm not sure, there we go, message with authentication dot is equal to. Now here I'm gonna have this type of string. So I'm gonna have headers with authentication, then I'm gonna have authorization 1, 2, 3, 4, 5, 6. I'm going to have content type JSON, and I'm going to have body, curly braces, quotes, username, space equals space, John. Okay, so I have that. So I'm going to copy this and paste it. And this time we're going to have message without authentication. And I'm just going to remove the authentication here. Let's go ahead and run. And there is a difference apparently. Let's click to see what the difference is with or without. Okay, so I forgot to change this. Okay, now run that again. There we go. So we have our tests that are set in place so that our functionality doesn't change without breaking the test. So that is basically the idea. You set up a certain chain of handlers, or you could set up a tree of handlers as well. It really depends on how you want to structure your functionality here. And then your request passes from handler to handler without the client worrying about who should come next. Okay, the chain knows that once it is built, and then the functionality just processes the request and returns the correct result here. So that is the chain of responsibility design pattern.